We can use directly this one or showing the change in variable like this, h by x equal to k, then k tends to 0 as h tends to 0. We can write the standard limit. I have applied the theorem or rule of limit x tends to a fx into gx is equal to limit x tends to a fx into limit x tends to a gx. I have applied that, and as the angle of the ratio sine h by 2 is h by 2, we have to bring that angle. For that I have divided 2 h divided h by 2 at the denominator, and good morning students, welcome to btosacademy, welcome to my maths class. Already I have started differentiation in the earlier episode. Today I shall continue differentiation. First of all, finding derivatives of some standard functions or known functions. I first take algebraic functions. First of all, derivatives of these algebraic functions. First x to the power n, then log x to the base c, then e to the power x. My suggestion to students who are now reading class 11, when you follow these classes, better you take your copy and pen and start working out as I am progressing. First x to the power n, we start like this. Let y equal to fx is equal to x to the power n. Therefore, if x plus h is x plus h whole to the power n, so that f of x plus h minus fx is equal to x plus h whole to the power n minus x to the power n. First, you recall the definition of the derivative of fx, that is limit h tends to 0, numerator f of x plus h minus fx, denominator h. For that, first I take the given function as fx, also it is y, then f of x plus h, then we calculate f of x plus h minus fx and get this expression. Therefore, by definition, also it is used as using first principle, dy dx, that is f dash x is equal to limit h tends to 0 . Note one thing, you must always mention this original definition, then you put the values. Don't forget to write this. Now we put the value. Already we have worked out limits of such types. In this case, it will be better to change the variable. For that, the denominator is expressed as the difference of x plus h and x. Put x plus h is equal to say k. Therefore, k tends to x as h tends to 0. To use the standard form, we have to change the variable like this. Therefore, f dash x is equal to limit k tends to x k to the power n minus x to the power n by k minus x. This is quite similar to the standard limit. Limit x tends to a, x to the power n minus a to the power n divided by x minus a, that is equal to n a to the power n minus 1. Here a is x, therefore this is equal to n x to the power n minus 1. Therefore finally ddx x to the power n is equal to a into x to the power n minus 1. Next, let us find the derivative of log x. You are to follow the similar steps, just I start like this. Also, already I have discussed, this is log x, log natural logarithm, log x. In short, when base is e, we write it ln x. Then it will be now, as per the formula of logarithm, log a minus log b, that is equal to log of a by b. Therefore, this can be written as log base is e. Now, I am to change this. Remember, always in the first step you write the definition of the derivative, then you put the value of f of x plus h minus fx. Better you calculate this value earlier than this. Now this is x plus h by x. If we divide, we get 1 plus h by x. That means logarithm 1 plus h by x this will be h, not x. Now I see in standard limit it is log of 1 plus x divided by x. Here in place of x it is h by x. Therefore, we have to get here h by x. For that, follow. First of all, x plus h by x. When simplified, it will be 1 plus h by x. Now the derivative is h, and here we find log of 1 plus the term that is to be made here. Therefore, I write in place of h by x into x. Now, here h is the variable. Therefore, 1 by x will be taken outside into limit h by x tends to 0. As h tends to 0, therefore h by x will also be a very small number. We can take h by x tends to 0, then now you can change the variable also like this, or you can write directly here the value 1 by x into 1, because taking h by x equal to say new symbol as k, then it will be log of within brackets 1 plus k by k, where k tends to 0. Therefore, this is same as the standard limit, and we can use that. Or you can do like this. Is equal to 1 by x into limit k tends to 0 log of 1 plus k to the base e by k, taking h by x equal to k. Therefore, k tends to 0 as h tends to 0. We can use directly this one, or showing the change in variable like this, h by x equal to k, then k tends to 0 as h tends to 0, we can write the standard limit. Therefore, it will be 1 by x into 1, that is equal to 1 by x. Therefore, final step, ddx log x to the base e is equal to 1 by x. Remember, in calculus, base of the logarithm is e. If it is not e, then you have to use the logarithmic formula to take the base as e. Next, we move to third sum. Actually, you have to follow mechanically this method. Take fx equal to e to the power x, etc., and follow these steps. Just I use this format. Number 3. First, you note down those students or learner who are following this. Already I have told that you take your copy and pen and start working out as I am doing. Now, just I rub the function here fx equal to e to the power x, e to the power x plus h will be f of x plus h, then f of x plus h minus fx is e to the power x plus h minus e to the power x. Now e to the power x plus h can be written as e to the power x into e to the power h. Now you see e to the power x is the common factor. Now I put here this value, limit h tends to 0 e to the power x e to the power h minus 1 divided by h. Now here h is variable, therefore here e to the power x is constant that can be taken outside as per the law. Already this is standard limit, limit h tends to 0, e to the power h minus 1 by h, value is 1, therefore finally we get e to the power x, therefore you write finally already I have found derivatives of these three algebraic functions. Then I move to find the derivatives of few trigonometrical functions. First of all, sin x. Process will be same as discussed earlier. Let fx equal to sin x. Therefore, f of x plus h sin of x plus h. Therefore, f of x plus h minus fx is equal to sin of x plus h minus sin x. Now this is of the form sin c minus sin d. Therefore we use the identity 2 cos of c plus d by 2 into sin c minus d by 2. After simplification, it will be 2 cosine within brackets x plus h by 2 into sin h by 2. Follow the mechanical way. First take fx equal to the given function, then f of x plus h, sin of x plus h, then calculate this part and get this simplified form. Now you write, therefore, by definition, d dx sin x, you can write also f dash x, that is d dx of sin x is equal to, write the original form first, f of x plus h minus fx divided by h. Now I put the value, already I have got the value, limit h tends to 0 to cos x plus h by 2 into sin h by 2 by h. Now we have the standard limit x tends to 0, sin x by x, that is equal to 1. Here we are getting sin form, but the angle is h by 2. To get the standard form, we rewrite this like this, limit, I write first h by 2. Now these 2 can be taken at the denominator of the denominator, and h tends to 0, therefore h by 2 tends to 0 into limit h tends to 0 cos of x plus h by 2. I have applied the theorem or rule of limit x tends to a, fx into gx is equal to limit x tends to a fx into limit x tends to a gx. I have applied that, and as the angle of the ratio sin h by 2 is h by 2, we have to bring that angle. For that I have divided 2 h divided h by 2 at the denominator and written like this. Now this is standard limit, the value is 1 into h tends to 0, we have to put here finally h equal to 0, therefore this will be cosine x. Therefore final step, d dx sin x is equal to cos x. d dx of sin x equal to cos x. Now students, you can calculate the derivative of cos x following the similar method, mechanical method, and you will get, I am not working out this one, it is to be done by yourself, so that you can improve your skill. Now I will work out tan x. We have found derivative of sin x, that is equal to cos x. Then if you follow the similar step, you will get number 2. I am writing the result, d dx cosine x that will be equal to minus sin x. You find yourself this one and see the result will be minus sin x. ddx of cos x will be minus sin x. I am now going to find the derivative of tan x. For that, as the steps will be mechanically same, I have kept the other format same. In this case, it will be tan x. Therefore, f of x plus h will be tan of x plus h. Therefore, if we simplify this, it will be tan of x plus h minus tan x. Now, to use the standard limit, we have to simplify this one. How? Tan can be written as sin by cos denominator will be cos of x plus h into cos x. It will be sin of x plus h into cos x minus cos of x plus h into sin x. Now this is of the form sin a cos b minus cos a sin b. That means it is sin of x plus h minus x divided by cos of x plus h into cos x. After simplification, it will be sin h cos of x plus h into cos x. I have simplified and got this form. Then, by definition, this part will be changed. It will be limit h tends to 0 sin h cos of x plus h into cos x. Now sin h by h, limit h tends to 0, that is standard limit. That is why I write like this: limit h tends to 0 sin h by h into 1 by limit h tends to 0 cos of x plus h into cos x. The value of this one is 1 into h tends to 0. Finally, we have to put h equal to 0, and this will be 1 by cos x into cos x. Therefore, this is sec square x. Therefore, ddx of tan x will be equal to sec square x. Next, 3 trigonometric functions I have taken, though I shall work out 2 out of these 3, and students or learners are to work out yourselves, the other. First of all, cosec x. fx, let fx equal to cosec x, therefore f of x plus h cosec x plus h, therefore f of x plus h minus fx is equal to, cosec means 1 by sine, therefore I write one by sine x. Why we have taken this way? Because we have to use the standard limit, limit x tends to 0, sine x by x, that is equal to 1. Now we simplify. Now if I take minus sign outside, sine of x plus h minus sine x, that means 2 cosine x plus h plus x by 2, sin c minus sin d form 2 cosine c plus d by 2 into sin c minus d by 2. Therefore, using first principle, f dash x is equal to limit h tends to 0, f of x plus h minus fx divided by h. Now in place of f of x plus h minus fx, I put this value, limit h tends to 0 minus 2 cosine x plus h by 2 sine h by 2 by sine of x plus h into sine x. Now you see h is the variable, therefore this sine x is constant in this case. It will be taken outside 1 by sine x. Minus 2 is also there, we can take that. This into limit h tends to 0 cos of x plus h by 2 by sine of x plus h. Actually putting h equal to 0, finally the expression or the fraction is not undefined, therefore I take this part together and there is sine h into limit h tends to 0 sine h by 2 into, to get the standard limit form, I divide the denominator h by 2 into, for adjustment it will be half, therefore minus 1 by sin x into, putting finally h equal to 0, what we get? It is cos x by sin x, and this becomes 1. That means minus cosec x 1 by sin x, that is cosec x, and cos x by sin x, that is cot x. Therefore, ddx final state of cosec x will be equal to minus cosec x into cot x. Derivative of cosec x, we have got the result minus cosec x cot x. Already we have followed mechanical way and calculated the limit. Already it is mentioned that derivative is nothing but obtaining the value of limits. Thus, derivative of cosec x is minus cosec x cot x. Now, students, you do yourself the derivative of sec x following similar way. As it is sec x, therefore we have to write here 1 by cos x, cos of x plus h, and 1 by cos x. And finally, you will get, I am writing down the result directly here, and you do yourself ddx of sec x is equal to sec x tan x. Next, I work out number 6, that is derivative of cot x. Though that will be similar to finding the derivative of tan x, I am working out that. I rub these. Therefore, f of x plus h minus fx will be cot, that means cos of x plus h by sin of x plus h minus cos x by sin x. Now we simplify sin of x plus h into sin x, sin x cos of x plus h minus cos x sin of x plus h. Now this is of the form sin a cos b minus cos a sin b. Therefore, numerator will be sin x minus h, sin x plus h into sin x. Here x cancelled. Therefore, minus sin h by sin of x plus h into sin x. We have got the simplified value of f of x plus h minus fx, that is equal to minus sin h divided by sin of x plus h into sin x. Now I put this value here, and remember one thing, while you will be asked to find the derivative of a given function, using definition you must write such type of terms using first principle or by definition, like this. Limit h tends to 0 minus sin h sin of x plus h into sin x. Now you see sin h by h there, therefore we are getting the standard limit, therefore ddx of cot x is equal to minus sign is taken outside into limit h tends to 0 sin h by h into limit h tends to 0 1 by sin of x plus h sin x. I have applied the theorem or law of limit x tends to 0 fx into gx or fx by gx, that will be equal to limit x tends to 0 fx numerator and denominator limit x tends to 0 gx, and finally or this form. Now this is standard limit, therefore minus 1 into, we have to put finally h equal to 0, what we get sin square x, sin x into sin x, sin square x, that means minus cosec square x. Therefore finally ddx of cot x equal to minus cosec square x.